Hi, this is Christin. I'm an automotive applications manager in TI Automotive Connectivity Department. Right. Today, I will spend a little bit of time talking about the seamless connection handover using Bluetooth Low Energy Protocol for the enhanced car access user experience. So, here is the agenda. Right. And so first, we will introduce, what is the typical vehicle car access system. And then we're going to talk a little bit about why we want the connection handover. What is it addressing? And then we will move on to what is the existing solution using a different protocol, not Bluetooth Low Energy, like the same as the handover, but not the Bluetooth Low Energy protocol. Then we will start going into what is TI's solution when it comes to connection handover, and then we'll go through all the more detailed sub-bullet point there. I'm sorry. And then I will have a slide showing, with a video attached, showing like the TI's connection handover performance and demo. Like there will be a video with the demo there. And then we will cover a little bit more advanced vehicle access use case, connection handover combined with channel sounding. And then close it with the summary. So first, this is a typical vehicle access system. You have anchor nodes, you have gateway nodes. So on the gateway nodes, right, you will have a probably more powerful processor to decide whether you're allowed to start the engine, whether you are allowed to unlock the car, or turn on the headlights, stuff like that. And then you also have something called anchor node that usually just have Bluetooth Low Energy together with an ultra wideband device. And then a typical use case is, right, when you use digital key, phone as a key solution, you go into the range between 2 to 20 meter, 3 to 20 meter, doesn't really matter, it's user defined. And then the phone will establish the connection, doesn't matter which node, as long as it sees it, it will connect. ECU will be in the sleep mode in this stage, and then the pre-localization would happen, right? So pre-localization, you could use RSSI solution, you can use channel sounding solution. But pre-localization give you whether, like, okay, if you're in the welcome zone, what is the usually action? Like you would turn on the door lights, or the handle lights, or headlights, or like, project the OEM logos on the ground. Then the next thing you will do is when you go closer and closer, you go to a zone called localization zone. Then you're still in connection. You don't need to do anything about it. The gateway will be active. Then at that point, you wanted to make sure that you get a precise distance resolution when it comes to when you enter the localization zone, because you need to know whether you need to unlock the car or not. You don't want user to stand there for like 2 seconds and holding the handle, not being able to open it. So that at that point, right, you will go into a channel sounding ranging solution, or even ultra wideband solution to provide more accurate result instead of to prevent that user gets what we usually call penalty stand, right, on the car. So yes, on top of that, you also, once the car is unlocked, as a phone as a key system, right, you need to make sure your phone is actually in the car. You don't want to start the engine when you are still standing outside. So you also use like channel sounding to locate, see if you're actually inside the car, to make sure that whether you're allowed to start the engine or not. Right, so this is, again, a typical car access system. And then why do we need connection handover? Right, so again, all in the vehicle, there are multiple nodes advertising at the same time. The peer device, here I'm using a phone as a peer device. So the peer device, it just sees the name of the advertising data and then connects it to one. It doesn't know which one it connects to, and it should not need to know. That's the purpose, right? You should not need to know. But again, once, for example, you go into here, you connect to these nodes. It doesn't need to know, but then if you have to all of a sudden decide, oh yeah, I'm carrying a lot of groceries, right? I need to go to the trunk. I don't want it to stay there. I'm gonna go all the way to the back. So you move to the trunk, and all of a sudden that, because it could be you're packed with all the different cars, it could be an indoor parking lot with a lot of concrete nearby. So the signal becomes degraded, right? You're starting to lose package because there's a lot of Bluetooth low energy data transactions going on the moment you're starting to get closer to the car. It's changing a lot of data, deciding whether you wanted to do CCC protocol or even different protocols or proprietary protocol as well on the data communication. So when you're starting to lose data, it would make the response towards the car, towards the system, slower, right? Even though there's a retry, but it's still not wanted. So the reason we wanted to be able to have a handover is because we wanted to make sure that we don't end up in the horrible link budget that's creating the package loss and disconnection. And on top of that, the reconnection latency, it's unknown, right? Each phone behaves slightly differently. Some of the phones, upon retry, it will go slower and slower. So then your penalty stand will go longer and longer. which is why that we introduced the seamless Bluetooth low energy connection handover between the vehicle nodes to avoid the disconnection. On top of that, right, you also wanted to make sure whether you are in the car or not. Like, for example, if you only connected to this device, you wanted to see if it's here, and then it will make more sense to hand over your nodes to here, and then you can have a inside the car check to see if your phone is actually in the car, whether you're allowed to start the engine or not. So the existing solutions for different technology, right? You have Wi-Fi. Wi-Fi there is always roaming. You don't know, right? You don't want to have to connect it to a different Wi-Fi network manually all the time when you go from one room to another room. So on the typical Wi-Fi roaming, you have access point, which is the router, whatever, that's allocated inside the different rooms, different hallways, and then you have your phone as a station. So basically that, your station will use the downlink of the RSSI to check that whether I'm having good enough signal or not. And then if it's not good enough, you will actively search for a better signal and then do the handover. Also, that was also participated by the access point as well. Right. The reason for talking just briefly about this is not the focus of this topic, but the reason for talking about this is like the principle of the Wi-Fi roaming. It actually is not transparent to the peer device, right? Both access point and the station, they need to be aware of the whole process, and they both know, okay, now I need to dump my connection data to the other device. The Bluetooth low energy connection handover is transparent towards your phone. So basically for all the phone vendors or the key fob, right, they don't need to handle anything. For them, everything is the same. They just see it's one connection. It doesn't need to know like, okay, now I connected to a new node. No, they don't have to know. So that was the importance of Bluetooth low energy connection handover. That's how we can scale to the market, right? You don't need every phone to be able to do this. The silicon, the software is able to provide this functionality to you. Okay. So then we will talk a little bit in detail on what TI what's the TI connection handover solution overview and proposal, right? So we will go into details on each point in the following slide. The first thing is that at the critical part, all the vehicle nodes, right? You have more than one node on the vehicle. All the vehicle nodes, act as a single point. For the phone, it only sees one device, even though you have 5 devices advertising at the same time. But your phone sees only one. It will connect it to one device, right? And then connection handover, it happens at the Bluetooth low energy protocol layer. So it is a Bluetooth low energy, you have a controller, you have a host, everything happens It changed everything. It shifted everything from one to two to the other one. And then later we will talk a little bit on the connection over triggering options. Of course, that there are more. It's based on your system design, but we have like 2 proposals in this presentation. The final one is that we're going to talk a little bit on the system level connection handover process. So it's one level up. We're not going to talk not much detail, but we will talk a little bit on how it should work. So first point, all the Bluetooth low energy nodes around the car, they act as a single point of entity. But how does that work? What do you need to do to get it to act as a single point of entity? First, all the device, you need to share exactly the same Bluetooth device address, right? So when the phone connects to it, it will be able to understand that's that device. On top of that, because you wanted to have a privacy, we increase the security of the connection. So all the devices, you need to share something we call identity resolving key, IRK. So everyone needs to have the same IRK. That means that once I connect it to node A or node B, I have the same IRK, I will resolve into the same Bluetooth device address. So for the phone, it will be the same entity. And then the process is that when you commission the card, you got the new card, you connect and pair and bond. When you do the bonding, you will have the information of IRK and also your encryption keys, right? And those information will go through the CAN bus or other wire protocol, could be Ethernet as well, towards all the other nodes. Doesn't have to be which node has to do that first. There is no definition. As long as the first one that gets connected can distribute the information to the rest of the system, then that's it. You don't need to multiply it, and you don't need to do it multiple times, right? So once you've done that, for the consecutive connections, right, all the nodes, even though you can see that in this picture, you have 4 nodes, that's advertising. Even though they could all use a different random private address, but based on the IRK and the BD device address, then they will resolve to the same thing. So for the peer device, paired phone, it will only see there's only one device, right? So it can ensure you can always connect because you will have the coverage around the car. And what happened is after the connection. Okay, so that's basically, this is step 1. Secondly, right, connection handover. On the TI's software solution, right, we hand over. So first off, we talked about the Bluetooth low energy stack, but the protocol stack contains a controller layer and then the host layer. The both layers contains different informations, right? The controller layer, it contains the channel map, the hopping sequence, the access address. That's the fundamental of how the package looks like. On the host layer, it contains all the security manager related information, which is your IRK, your long-term key, encryption keys. So in TI's connection handover solution, we basically hand over all the needed information from both host layer and controller layer to the peer device. In our terminology, right, we call, so here you see that here there's something called serving card node. Serving card node, by definition, it's the node that gets connected first. The one that has the connection is giving away its connection, so it's serving a connection. So we call it serving card node. And then the peer device that's about to take over, it's the candidate to take over the connection. So we call it a candidate node, right? Yes, so then you can go through a wire link, CAN bus or Ethernet to transfer the data and then to hand over the needed information for the protocol stack to continue the execution at half point, right? If you're familiar with the Bluetooth stack protocol, there is so much stuff that's connection based. Different connection events. There is a lot of what's called sequence number, those kind of stuff. So it needs to be transferred to the peer device in order for it to successfully continue the connection. And then the amount of data that we need to transfer, it's based on what the protocol you wanted to do. For example, if there is no profile, there is no L2 cap COC, then at a controller layer, the needed amount of data, of course, we're talking about encryptions as well. So at controller layer, you will need to transfer 272 bytes from one device to the other device through your wired interface. At the host layer, if we including, for example, that channel sounding handover, which you also have something called ranging profile that was defined by the Bluetooth specification. So you need to include the data for the ranging profile together with the control layer. So the total amount of the bytes is about 600 bytes. Then now we covered a little bit about how TI's offering covers, and then now we're gonna cover a little bit on who decides what we're gonna do the handover, right? So first off, you have, in our previous definition, right, in the welcome zone, in the localization zone, the ECU is awake or not awake. So now we're gonna talk a little bit about, first, if your phone is a key, your phone is in the localization zone. So then your ECU can perform the localization. Basically that if your D1 connected to the anchor node, because it doesn't care which node it connects, it could be the anchor node can start doing channel sounding while the rest of nodes is doing connection monitor. So basically monitor the active link between the phone to these nodes, right? Then all the nodes will get 2 RSSIs from this and this and this to this. So based on the RSSI of the phones from multiple points, then you can do a trilateration to figure out where that phone is. And then you can send the data to the gateway node. Then the gateway node can say, hey, and on top of that, you also have the channel sounding data coming out from this node. So you will do all the comparison and then say, hey, actually you are closer. So that's transfer the connection from this one to this one, right? So there is someone summarizing the data. And then the data, it comes from all the different methods, from channel sounding, from RSSI, right? So if you have another scenario where you are actually only in the welcome zone, then you don't have a main gateway. But again, all the nodes, they have a CAN bus also connected towards each other. So in TI solution, you can connect, and then you will be actively having connection RSSI and also channel sounding as well when you are doing the ranging. And the rest of nodes is monitoring this link, and this link and this link right here, right? Then you get all the RSSI. Then you can send the data to the one that's in the connection. He can go decide, right? So the one that's in active connection can decide, okay, I'm running channel sounding, and I also have RSSI, and other node also sees the RSSI. Then at least I have more reference points with different technology all at the same time to decide whether, okay, I don't think I have that, my range isn't that good. I could change to this one. So there are different scenarios. Either you use ECU when you are in the localization zone, or you can just use the anchor nodes when the ECU is in sleep. So here, we cover, the system, the deciding, and then the BOE stack on the handover where the controller hosts. Now we're just gonna go a little bit about the whole sequence, how it should be done. Okay, so first you connect to the serving node. There is a bus ongoing, right? And then you do channel sounding, connection monitor, where is, our TI turn connection monitor is just monitoring the connection, getting RSSI. Someone, either ECU or either anchor node, decided that, okay, I'm triggering connection handover, right? Before you do the triggering, you first do a time synchronization first, because on this device and this device, all the embedded device, they power up, their clock is not the same. There's no identical clock on 2 hardwares, right? It's a free running clock the moment you power it up. So you need to map my time readout at time 1. How do I map it to the time readout at time 1 at this device? So this is what we call a time synchronization. The point of knowing the time is that once I gather all the data about to transfer everything, I know that, okay, the previous connection happened at this time. And that maps to my clock readout of this. So the next connection now, I get all the parameters, and I'm about to start. I can know the connection parameters, so I will know at which of my device clock time I need to start the TX or RX, right, based on your role. So we do a timing synchronization first, and then before handover, our solution will we will make sure all the application data is being sent first before we actually doing the connection, right, handover. And then we will block the RX and TX path, but that's just for the application data, not the empty package, because the connection still needs to be ongoing. Then once the data is transferred, the candidate nodes, it will, based on the timing synchronization, trying to open either TX or RX at the correct timing to start the connection from the phone, trying to take over. And the TS solution is that we have a callback, right? If it's successful, then we will send both, either whether it's successful or not, right? If it's successful, then you will get the callback saying successful, and then you're starting to get the connection informations. If it failed after a customer decided number of connection events, then you also send a callback to the serving node. So if the serving node gets the callback saying that, hey, I'm successful, then the serving node will just be done. I'm done with this connection. And now application can do is that it was on active connection. Now it has no active connection to do. You can go into a connection monitor role. So then it doesn't become useless. It doesn't become redundant. It just goes to a different role to provide additional information. If the handover failed, this node will continue to resume the connection. So for the digital key point of view, there is no difference, right? Either it's successful or failed, the connection is still here. If the successful message or failed message is not received, we will resume the connection anyway, and then we will notify this node. Here, I'm gonna show a little bit on our measurement setup and then present benchmark, and then they will come with a video of connection handover. So here we use a TI Launchpad. You can get it on ti.com. Everyone can just go and get it. You don't need to request for sample. And then you will also get a TI TCAN device. So this is a setup, 2 sets of identical setup. And so the CAN is connected with a 3-meter cable here. And then we also use 2 phones to connect it to it. So this is just a sequence, a diagram to show how the connection I just talked about. But here we also do a logic analyzer. The point for logic analyzer is going to be what I'm going to present in the next slide will make sense, will make more sense once we use the logic analyzer. But basically what we're trying to do is that in your application layer, if you say, hey, I'm gonna do connection handover, right? The moment you send the data of the connection handover to the moment the other device successfully captured the connection, what is the time passed in doing this process, right? If the time passed during this process is like 10 connection events, it's not acceptable, basically. It's just too long. You're missing 10 connection events, or it just takes too much time. So the test setup is like this. So logic analyzer is the one we use to get the detailed information on how much connection events it takes. So the test setup, we use CAN. We are running on the 1 megaphi on the Bluetooth Low Energy at 1 megaphi. We test both the 30 millisecond connection interval, which is the typical use case in the phone as a key. And then we also tested the extreme case, which is 7.5 millisecond as well. And then we test 30 handovers. Per test case, there is going to be 3 test cases where I'm going to present the result. And number of phones up to 2. And the handover layer is just a basic get layer. So it's not a ranging profile. We didn't hand over the ranging profile. So here is the result. We have 3 different test cases. The first one is only one phone. We basically ping pong it back and forth, right? So repeated handover with 1 second interval. The other one is that we connected to 2 phones first, and then each phone, they have handover to the peer device at their own interval, but 1 second interval. And then the third one is 2 phones, handover, but a random interval. There's no, we just generate a random number, and then you do a handover 30 times. Here is the result, right? So all the test cases, 30 times with 2 nodes, are successful. All of them shows that it is 30, so more than 25 out of 30, we were able to hand over the connection within 1 connection event. So within 30 milliseconds in this case, because this is the 30 millisecond interval slides. Some of them takes 2, but again, all of them success 30 under 30, and the majority use only 1 connection event. At the 7.5 Bluetooth Low Energy connection interval, all the single connection handover we measure up to completing within 2 connection events as well, so which is within 15 milliseconds. So here's the demo. How can I, let me start. So here's the demo. This is my colleague, Evan Wakefield. So he's standing there for some time because he's connect pairing and bonding to that single node. And what happened is that he will walk towards the other node. The nodes that gets connected or gets handed over, the green light will show. And then once it gets disconnected, and then that one take over, that one, the green light will show. It's right here. So he just walk back and forth, and then the connection handover, this one is simple RSSI solution. So based on the RSSI, this one, when the RSSI is too low, he will say, I wanted to give it to you. So basically, this is the handover. Sorry. Yeah, so we're close to the finish. So again, during the overall presentation, right, we talked about we are also doing channel sounding, so you can also combine the connection handover together with channel sounding as well. So you could hand over, basically, you could do this one, for example, if you connected to this one first, this one do channel sounding, and then the rest was gathering the RSSI information, then you hand over to this one, while this one will become the RSSI monitoring, and this one does channel sounding. And you get more data points with more different nodes and then different technology to make a more assessment. So the more data point you can get into the same amount of time, of course, then you will get a better ranging result, right? With the channel sounding, so we are able to finish the connection handover with about 2 connection events as well. I'm about to finish. So again, the bottom line of this presentation, right, is TI offers the connection handover with performance benchmark. We think everything is within 2 connections events using 30 milliseconds or also 7.5 milliseconds. And then we also offer connection handover combining with channel sounding and also role switching. Right after you hand over, you go back to the RSSI monitoring, even though you are not on the active connection. So the most important part is the whole process, even though it sounds very complicated, a lot of technical information, but it's transparent towards the phone. So the phone and then the key fob has nothing. They don't need to do anything. Everything was just transparent. Yes, I think that's all. Thank you for your attention.